Hey everyone, we're going to take a look at number 15 in section 4.5 real quick here, and we're going to evaluate the limit using L'Hopital's rule. A couple things to recall here. We've got some exponential functions here, 7 to the x and 5 to the x. First of all, recall that from exponents, a to the 0 power is always 1 for any base not equal to 0. And from calculus, we've learned earlier that the derivative of the general exponential function a to the x is the natural log of a times a to the x. Of course, a, the base, is greater than 0, not equal to 1. So for instance, e to the x, right? In particular, we know natural log of e is 1. This gives me 1 times e to the x. Derivative of e to the x is e to the x. But derivative of 2 to the x would be natural log of 2 times 2 to the x, right? Where natural log of 2, again, is the exponent on the base e needed to get 2, from the log of 2. Okay, so after that quick recall, let's plug in and see what we get. Well, obviously in the denominator, we're going to 0. 7 to the 0 is approaching 1. 5 to the 0 is 1, right? So the top is approaching what? 1 minus 1, which is 0. So guess what? We're L'Hopital rule form. Remember L'Hopital rule form, 0 over 0 or infinity over infinity. Okay, so I can now apply L'Hopital's rule. I take the derivative of the top, right, over the bottom. Don't forget, and the derivative of the bottom. Don't forget I have the limit here. And again, when I use L'Hopital's rule, I put the L above the equal sign to indicating I'm using it, and I would want you to do that as well. So what's the derivative of 7 to the x? Well, we just talked about that right here. It's going to be natural log of 7 times 7 to the x. And what's the derivative of 5 to the x? Well, it's natural log of 5 times 5 to the x. Derivative of x is just 1. So now notice I can plug in directly. Obviously, being over 1, it's just the numerator here. Plug in 0 here and here. 7 to the 0 is 1, 5 to the 0 is 1, and so I get the natural log of 7 minus the natural log of 5. And that's a fine answer. If you're doing the test for me, that's fine. You can write this a little more compactly if you remember this relationship, this property of logarithms. The natural log of a divided by b, remember, is the natural log of a minus the natural log of b. So looking at this way, going in this direction, I can rewrite this, right, log 7 minus log 5 as the natural log of 7/5. So it's a little more compact, nice way of writing the limit. I hope this one is helpful for you.